Right, clustering is a task where the goal is to find groups in a given data set, so that within group the data set, the 8 items will be similar to each other, and between groups they will not be very similar to each other. Just to make it more concrete, basically imagine like boxes, like images. Like let's say we have images of square shaped boxes and round shaped boxes. Basically, we would want to, in this case, we would want to expect that the groupings will reflect this shape variation, meaning round shaped boxes will be in one cluster and the square shaped boxes will be in the other cluster. And something very characteristic about clustering is it's an unsupervised task, meaning we don't have a training set where we say this data item is cluster 1 and this data item is cluster 2. We don't have this. We just give an algorithm a data set, and it's expected to return a good grouping, meaningful grouping, meaningful clustering. So because it's unsupervised, we basically need to pick a right model so that we get a good, meaningful grouping. So basically, what do I mean by this? More specifically, what I am thinking about is the clustering geometry. So depending on your clustering geometry, basically the right algorithm to use changes. So if you know that you have like compact clusters, convex shaped, to be more exact, clusters, something like an algorithm called k-means algorithm would work well. So to be more exact, let's just to simplify things, let's say we are in 2 dimensions, and y-axis is the shape axis and x-axis is the color axis, let's say, all right, for these images of boxes. If we know that our variation in the data looks like this in 2 dimensions, basically k-means algorithm would work well. But if we have something like a case like this, where we have 2 groups where this upper group tends to have more variation along the color side, and it's like a more variation. It has more variation, and it's like a particular. It has a particular structure to its variation. Then an algorithm such as k-means, which assumes that these clusters are of or of same size and there are these compact shapes, it's not going to work well. Now we need to modify our algorithm so that the cluster shapes can be ellipses. All right, an algorithm which does this, it's a model, and there's an algorithm to learn this, but to accommodate for this situation, we can use an algorithm called a model called Gaussian mixture models, which allows the clusters to be ellipses essentially. But if let's go even weirder, we can actually have like a situation like this where clusters look like these rings, right? One cluster is here. It looks like one cluster is this ring, outer ring, and the other cluster is this inner ring. So even assuming that the clusters are ellipses will not work here. I mean, I don't know. I guess it will probably try to like divide this into half or something. Like it's not gonna work. In this case, basically, what we can do is we can we need to consider basically similarities between each other. Like what seems like it's like the clusters in each ring, in data items within each ring, they kind of have this like this neighborhood structure, right? So like this connectedness, so to speak, like structure. So basically, we need to use another paradigm for clustering here. We need to there are these algorithms which are based on forming similarity graphs, and then basically based on the similarity graphs, it tries to partition the graph into two. And one such algorithm is called spectral clustering, and it would work much better in this situation. The clustering geometry is very, very essential. Like we need to know how our clusters look like in order to be able to pick the right algorithm for our data set. And the other consideration is the data set size. Basically, if we have a very large data set, using an algorithm such as k-means or Gaussian mixture modeling would be a good idea, because these algorithms scale linearly in terms of number of data items, whereas a graph-based algorithm which requires us to compute distances between all data items would scale quadratically. Basically, just square the runtime will be proportional to the square of number of data items, which will be prohibitive for the larger data sets. Okay, to wrap up, when you pick a clustering algorithm, you need to know what your clusters look like. So if you're in high dimensions, what you can do is you can try to visualize what they look like in lower dimensions, and then depending on that, you can try to pick your clustering algorithm. And the other consideration is size. If you have a larger data set, k-means or GMM will be a better choice. But if it's a smaller data set, you can afford a graph-based algorithm. All right, yeah, depends on what you want to do and your data sets.